All right, let's talk about one of the biggest headaches in the digital world, blockchain scalability. We're going to take this super complex topic and break it down, turning it from a frustrating traffic jam into a high-speed expressway of understanding. And we'll start with a question you've probably asked yourself.
You know that feeling, right? You get super excited about some new technology, but when you actually try it, it's slow, or clunky, or weirdly expensive. That feeling of being stuck in digital traffic is right at the heart of the problem we're going to unpack today.
Yep, that's what we're talking about, digital gridlock. It's really the one thing holding blockchain back from, well, from everything it could be. So to solve it, we first have to understand what's causing the jam in the first place.
So what exactly is this massive traffic jam? At its core, it's a scalability problem. See, as more and more people started using blockchains like Bitcoin and Ethereum, the networks just couldn't keep up. They started to slow down, just like a city's roads during rush hour.
To get why blockchain is slow, we first have to look at what's fast. Think about your bank, or Google, or any big tech company. They're centralized. Information just zips through one main point, one powerful server that calls all the shots. It's a direct route, and it's super efficient.
But here's the thing. Blockchains were designed to be the exact opposite of that. They were built on a totally different principle.
They're decentralized. And this is so important because it's both their greatest strength and, honestly, their biggest weakness. Instead of one boss, you've got thousands of computers, we call them nodes, and they all have to agree on every single transaction. It's what makes it so secure, but man, is it slow.
Just how slow are we talking? Well, take Bitcoin, the OG blockchain. It takes around 10 minutes just to confirm one batch of transactions. Can you imagine waiting 10 minutes for your coffee payment to go through? Yeah, no way. That's the gridlock we're dealing with.
And just like in a real traffic jam, when the network gets clogged up, things get ugly. The fees to get your transaction through, the gas fees, they just skyrocket. And the delays, they become a total deal breaker. It's just not practical for, daily life. So what's the fix?
Well, the first idea was pretty straightforward. If the road is jammed, let's just widen the road. These are what we call Layer 1 solutions. They're all about trying to fix the main blockchain network itself.
So Layer 1, or L1, that's the base blockchain. That's your Bitcoin, your Ethereum. It's the main highway system of this whole decentralized world. L1 solutions are just trying to make those main roads bigger, faster, and better. And how do they do it? Well, there are a few ways. You could increase the block size. That's basically like adding more lanes to the highway. Or you could upgrade the consensus mechanism. Think of that as installing way smarter traffic lights to manage the flow. And then there's something called sharding, which splits the main road into a bunch of parallel routes.
Now, all of these are really important upgrades, for sure. They definitely help. But they have their limits. At the end of the day, if the number of cars is growing like crazy, just widening the road isn't going to cut it. You're just setting yourself up for an even bigger traffic jam down the line. We needed something different.
And that need for a totally different approach brings us to our next big idea. Instead of just making the main road wider, what if we built a super fast expressway right on top of it? And that right there is the big idea behind Layer 2 solutions. So a Layer 2, or L2, is a separate system that's built to work on top of the main Layer 1 blockchain. What it does is it pulls most of the traffic off that congested main road, processes it like lightning on its own expressway, and then just sends a summary of the final results back down. Pretty clever, right?
This really breaks it down nicely. Layer 1 tries to make small, steady improvements on the main chain. But Layer 2, it gives you these massive exponential speed boosts by taking things off-chain. It's literally the difference between widening a local road and building a brand new multi-lane expressway.
Okay, so how does this expressway actually work? More importantly, how does it stay secure without the main road constantly checking up on it? The magic behind it all is a technology called rollups. Rollups are honestly a genius trick. They take hundreds, sometimes thousands of individual transactions that are happening up on the Layer 2 expressway, and they bundle them all together. They roll them up into one tiny compressed piece of data. Then they send just that one piece of data down to the main Layer 1.
But that leads to a really important question, doesn't it? If you're only sending a summary, how can the main road possibly trust that the summary is correct? How does it know all those transactions on the expressway were legit without checking every single one?
The answer is some really elegant math, a cryptographic trick called a Merkle tree. A Merkle tree can take a whole bunch of data, like all those transactions, and basically boil it all down to a single, unique digital fingerprint. We call this the Merkle root. And what's amazing is, if you change even one tiny little detail, the entire fingerprint changes completely.
And this visual just nails it. You've got the Layer 2 expressway handling all the individual cars, or transactions. The Merkle tree then creates one single super secure receipt. That's the Merkle root. And that one little receipt is all Main Street the Layer 1 needs to see to know, instantly, that the entire batch of transactions is totally valid.
And as this quote points out, it's all about efficient verification. It lets you prove that huge amounts of data are valid without jamming up the main chain. You get the best of both worlds, the incredible speed of the expressway and the rock-solid security of the main road.
Okay, so we've gone from a frustrating traffic jam to a high-speed expressway. But why does all this technical stuff really matter? Well, it matters because fixing this scalability problem is what finally unlocks what this technology can actually do for all of us.
Once that traffic jam is cleared, a whole new world of possibilities just opens up. We're talking about running seriously complex smart contracts, building real peer-to-peer economies without giant companies taking a cut, and actually verifying where our products come from. The potential is just huge.
So the digital gridlock is finally starting to clear up. The expressways are here. And that leaves us with one last, really exciting question to think about. Now that the blockchain can finally move at full speed, what are we going to build next?